Hello, today we're going to be doing a video on integration using partial fractions. Integration by partial fractions is a good technique to use when you can't have a polynomial on top and bottom and can't use substitution or break the integral apart the traditional way.
So the way we break this integral apart to enable us to integrate it is that we take this term in here and we set it equal to some constant over the denominator. Well, some constant over the first term of the denominator plus some constant over the second term of the denominator. And we know these must equal because when we cross multiply the denominator of the original term, we can eliminate these denominators and then solve for a and b. So we're going to do that. So we get, when we cross multiply this equation, we get a times x minus 2 times x plus 5 over x minus 2 plus b times x minus 2 times x plus 5 over x plus 5 equals x squared plus 2x plus 6. So now you can see we can eliminate these terms in each of the terms here. So we get a times x plus 5 plus b times x minus 2 equals x squared plus 2x plus 6. Now there's an easy way to solve for a and b, and that is just to simply plug in values for x that will eliminate one of the variables. So first plug in 2 for x, then we get 7a because of 2 plus 5a. Now the b is gone because it's 0b. We plug in the 2 for x on the other side as well. We get 4 plus 6 is 14. Therefore a equals 2. Now we'll do the same thing to eliminate a. Put in minus 5, and that gets rid of the a. And then we get negative 7b equals, plug in the minus 5 on the other side. Now 25 minus 10 plus 6 is 21. Therefore b equals negative 3. So now we have our a and b, but we're not done. We still have to integrate, which was our original goal. So now I'm just going to take this integral and redefine it as a over x minus 2 plus b over x plus 5 with the values for a and b plugged in. So we have the integral for 2 over x minus 2 minus 3, because it's a negative 3 for b, over x plus 5. Now we can break this integral apart into the two different parts now and just solve it by the simple natural log method. So what we end up with is 2 times the natural log of the absolute value of x minus 2 minus 3 times the natural log of the absolute value of x plus 5 plus a constant. And that's a pretty simple integration by partial fractions problem. Some of them can be a bit more complicated because they have higher orders of magnitude in the denominator, such as this problem. I'm not going to solve this problem because of the 10-minute limit for YouTube videos, but I'll just set it up so you can see how it's done. So when we break this up, we have three different terms multiplied together in the denominator. So we have a over x plus b over x minus 1. We can't simply use c for the third term because there's an x squared in this term, so we have to account for the possible x's as well as the possible constants. So we have cx plus d over the third term. And now you would do a bit of complicated algebra to find out those variables and then just plug this back in and integrate. You'd probably have to use the reverse arctangent integral to solve that last one. Another example is just a simple integral in which you can't break it up and it doesn't look like you can use partial fractions simply because you you just have it in a trinomial in the bottom. But you can factor this so that it becomes x minus 5 times x minus 1 instead of x squared minus 6x plus 5. And with that, you can then apply partial fractions. So it would be a over x minus 5 plus b over x minus 1 equals 4 over x minus 5 times x minus 1. And then apply the same method that we discussed earlier.
Okay, thank you for watching.